What's going on? Alright, so check us out. What we're going to be covering today is we're going to be talking about work and energy. It's a new concept that, let's see. It's a new concept that we're kind of covering. We're moving on from talking about kinematics, and then we've talked about forces. Now we're talking about work, and what's really interesting about work is it's kind of a new way to look at kinematics. We're going to go back to that, just kind of in this different light. The first thing I need to introduce to you is this idea of work. It takes work to get this pen to work. Work is equal to force times distance. There's your equation. Remember, physics is not about memorizing every single equation under the sun. It's memorizing a few equations, and this concept of work equals force times distance. This idea was brought up by this guy named James Prescott Joule, who was rumored to actually be able to even do physics at any time. He just loved it so much he did it on his honeymoon. I'd imagine that he wouldn't have been married for very long, but whatever, I don't know. I mean, my wife would kill me if I did that. All right, anyway, work is equal to force times distance, and so since he was such a big proponent of work equals force times distance, he was a big, he kind of research all of this stuff. We named the unit after him. So a work is actually a measurement in joules. It wasn't named after Jules Verne, another great science fiction writer, but it's measured in joules, named after William Prescott Joule. Now, one way, and the way we represent that is in J. So, what is J equal to? Well, joules is the same as, what is the units of force? The units of force is a Newton, so it would be Nm. Sometimes you can write joules, sometimes you can write newtons per times meters. Does that make sense? We can even further break this down if we wanted to. Remember, a force is equal to mass times acceleration, so a force, or a Newton, is actually the same as a kilogram meters per second squared multiplied by another meter, because you have Nm. So this part's the N, here's the M. So a joule is the same as kilograms meters squared per second squared, technically, if you want to think of it like that. So I can either say joules, and I could mean Newton times meters, and it's all the same if I say kilogram meters squared per second squared, or just say joules. Does that make sense for you, the units on that thing?